Okay, so in this video, we're going to talk about slope, which is the same thing as rate of change when we talk about linear functions. So first, a definition. So a slope is a ratio. Remember, ratio is where it looks like a fraction. It's the relationship between two quantities. So it's a ratio of the vertical change. Remember, that's the up and down to the horizontal change, so the left and right, of any 2 points that lie on a line. So let's get some of that written down. So slope, and I'm going to pretty much use slope and rate of change synonymously. So know that if I say rate of change, I'm talking about slope. And if I say slope, I'm talking about rate of change. So we're going to write this as a ratio of the vertical change, which is your up and down, to the horizontal change, which is left and right. Sometimes you'll hear the term rise, because if you think about rise, it's a movement up or down, to run. So rise, again, is your up and down movement, to the run, which is your left and right movement. To help just kind of flesh that out a little bit more, let's look at a graph. So the red section here, notice from this point to this point, we're going to move vertically and horizontally to get to that second point from the first. And the first movement is our up movement. So that's going to be our rise. And in this case, we're rising 1, 2 units. And then the yellow portion of the graph is our run. It's showing the horizontal change. And if we were to count the movement, we are running 1, 2, 3 units to the right. So our run is 3. And remember, our slope is our rise over our run. So our rise was 2 and our run was 3. So the slope of this line is 2/3. So big picture, slope just tells you the steepness and the direction of any given line. So let's move on, and we're going to talk about even more details related to slope. So first thing, really important concept, is that lines or linear functions all have what's called a constant rate of change. Think about it. If your slope was like this, and then it started speeding up, if whatever is changing in your scenario started going faster or changing faster, then your line would get steeper. And now it would no longer be a linear function. So in order for a function to be linear, it must have a constant rate of change. So highlight that, star it, do something to help you remember that lines must have a constant rate of change. Now, sometimes in order to find slope, you're going to be given 2 ordered pairs that lie on a specific line. If you're given 2 ordered pairs, then what you can apply is what's called the slope formula. The variable that we'll always use to represent slope is an m. So remember that as we move on, and know that anytime you see an m when we're talking about linear functions, it's referring to the slope. So here's the formula if you're given 2 ordered pairs. And notice, I want you to see one ordered pair is x1, y1, and one ordered pair is x2, y2. The 1s and the 2s on there don't have any meaning other than the fact that it's the first set of ordered pairs you're given and the second set of ordered pairs you're given. So here's the formula. It is y2 minus y1. So the change in the y's over x2 minus x1. Be careful, it's super, super common for students to flip those because we think often that x should come first. So think of slope as kind of feeling upside down. It's always the change in the y over the change in the x. And I want to relate that back to this concept. The change in the y, well, y is your up and down movement, so that's synonymous with rise. And the change in the x is left and right, so that's synonymous with your run. So all of these things connect and work together. Now let's talk specifically about the sign of slope as well as horizontal and vertical lines, because those have kind of a weird slope. So I want you to think about slope in terms of positive and negative by thinking about whether a car driving from left to right is going to be going uphill or downhill. So here we have a car driving from left to right. It's going uphill, and this has a positive slope. So one thing that you can always do to kind of double check yourself when you determine slopes of lines is to ask yourself if it's uphill or downhill, and then at the very least you'll know whether your sign of your slope is correct. So again, moving on, if our car again is going from left to right, and if it's a downhill line from left to right, then this is going to have a negative slope. And then finally, let's talk about horizontal and vertical lines. So I think about horizontal lines as like flat roads. And flat roads, I don't know if you guys agree with me, but I think they get super, super, super boring. There's no hills or valleys. It's just flat and boring. And if I was the passenger, hopefully not the driver, but the passenger of this car, then I would have the tendency to probably fall asleep on this drive. And that will hopefully help you remember that horizontal lines have a slope of 0. And again, just keeping our car metaphor going here, if you were driving and you came to the edge of a cliff, and that cliff is a vertical line, well, what's going to happen? The car's going to fall off the cliff, and when it gets to the bottom, it's probably going to be hard to tell what that car looks like. In other words, it's going to be hard to define it as a car because it's going to be so wrecked. So vertical lines have a slope that is undefined. So kind of cheesy, but hopefully will help you remember. I know it helped me remember when I was in high school. All right, so let's go ahead and we're going to talk about finding like numerical values for slope. So just like we did on page 1 here, we determined what the rise and the run were, and we then gave a numerical value for the slope. So let's do that with multiple representations. Now, just as a heads up, when I say multiple representations, I'm talking about graphs, tables, ordered pairs, practical scenarios, equations. Those all fit under the category of multiple representations. So first, we've kind of already done this, but let's talk about how to find the slope from a graph. So I've given you some bullet points here. Find 2 points somewhere along the graph that are easy to name. Like don't choose like 1.2 or something like that, but identify 2 points. And then what I think is the best rule of thumb to help you avoid careless errors is to always start at the left point and then count rise first. Just because up and down is helpful in understanding whether you're going to have a positive or negative slope, a little bit easier than left and right. So it's not a have to, but from my experience teaching, I think those are good rules of thumb. So what we're going to do is we're going to go along the line and we're going to identify some points. So we wouldn't want to identify like a point right here because we don't know exactly what that ordered pair is. But as we continue to go along the line, we see a pretty perfect ordered pair right there and a pretty perfect ordered pair right there. I could continue going, like I could have identified that point right there, I could have identified that point right there, and that point right there, and that point right there, but we really only need 2 points. So find 2 perfect points, and then those are the ones that we can use to find our rise and our run. So let's do our rise first. Remember I said start with the leftmost point and count rise first. So what do we do? To get from this point to this point, moving only horizontally and vertically, we have to go down 1. Hopefully when you think down 1, that's pretty easy for you to think it's a negative 1. Now from there, we're going to go right, 1, 2, 3. And if you always put the sign with the rise, then your run will always be positive. So the slope of that first line, remember slope is we use an M to represent slope. Our slope is our rise, which is negative 1, over our run, which is 3, and there is our slope, a negative 1/3. And that just tells us generally how steep or shallow the line is. All right, for B, let's do the exact same thing. So I'm going to go along the line and I'm going to identify 2 points. So let's say I identify, this is the first one I see right here, and then the next one I see is right here. You probably found 2 that were a little closer to each other, but I want to show you, even if you didn't find the 2 closest ones, it's okay. So let's go ahead, we're going to start with the leftmost point and we're going to count rise first. So here I'm going to go all the way up to there. Let's count how many jumps we did. So it's 1, 2, 3, 4, 5, 6. I went up, and up means positive. So it's a positive 6 for our rise, and then for our run, we're going to go to the right, 1, 2, 3, 4, and our run is always positive as long as the sign is with our rise. So our slope, represented by M, is 6/4. And as always, anytime you have a fraction or ratio that can be simplified, you need to go ahead and simplify it. So we need to go ahead and finally say that our slope is not 6/4, but in fact 3/2. Now, had I instead chosen this point right there, I would have automatically gotten 3/2 and not needed to simplify at the end. But you arrived at the correct answer either way. All right, so now let's talk about how to find slope from ordered pairs. This is where we're going to use that formula. So let me rewrite the formula over here. The slope from 2 ordered pairs is always y2 minus y1 over x2 minus x1. So we got to figure out, well, what's y2, what's y1, what's x2, what's x1. So let's label these ordered pairs. Remember, x comes before y in an ordered pair, and we're going to call this ordered pair the first ordered pair and this ordered pair the second. It's not wrong if you go the opposite way, but it's just kind of natural to say the left one is their first and the right one is our second. So remember, x before y, so that means this is x1, and then -3 is y1. So for our second set of ordered pairs, here's our x2, and our 12 is our y2. So now it's just an issue of plugging numbers into the formula and then simplifying. So let's do that. So here we're going to do y2, which is 12. So m is equal to 12 minus is from the formula, and then y1 is minus 3. Remember, I've told you it's a good rule of thumb to go ahead and put parentheses around negatives just so you can kind of see what's going on a little bit better. All right, on the denominator, we're going to do x2, which is negative 4. Minus is from the formula, and then 5 is our x1. So now from here, we're going to simplify. Remember, minus and negative is a positive. So on top, we're going to have 12 plus 3, which is 15. And then on bottom, a negative 4 minus 5 gives us a negative 9. So remember, we're not finished until it's fully simplified. So we need to divide the top and the bottom by that common factor of 3. So 15 divided by 3 is 5, and 9 divided by 3 is 3, and then remember our negative. So final slope is negative 5 over 3. All right, second example, let's go ahead and label our ordered pairs. So here's our x1 and our y1. Here's our x2 and our y2. So plugging into the formula, m is equal to y2, which is negative 8, minus is in the formula, y1 is negative 2, over x2, which is 6, minus x1, which is also 6. And here we can simplify. Remember, minus and negative is the same thing as plus. So we have a negative 8 plus 2, which gives us a negative 6. And then a 6 minus 6 gives us 0. So notice here we're dividing by 0. So this is that time where if you divide by 0, the world explodes, right? So this does not have a value of 0. This is an undefined value. So our slope here is undefined. And think about this. If we were to plot those 2 points, look at how that line looks. So if it was 6, negative 2, maybe it would be right here. And then 6, negative 8 might be right here. And notice what you have. A vertical line. And remember from that first page, vertical lines have undefined slopes. All right, moving on. What if the representation you have is a table? Well, the key here is recognizing that you have more information than you need. If you know that that table represents a linear function, then you can just choose any 2 points. So just choose whichever ones you want. You can choose the top 2. You could choose 2 that aren't even close to each other. You're probably going to have to simplify if you do. But choose any 2 points and then plug them into the formula. So again, I'm going to label those points. So here's my x1 and my y1. Here's my x2 and my y2. So plugging into the formula, m is equal to y2, which is negative 6, minus y1 is negative 8. Minus is in the formula, and then the negative 8 is the second y value. So then on the bottom, we have x2, which is 2, minus x1, which is 1. So now let's simplify. We have negative 6 plus 8. That gives us a 2, and then 2 minus 1 is 1, so our slope overall is 2. All right, and finally, we're going to do a little bit of a spiral review here, but then also talk about slope. So practical scenario is Noah has read 142 pages of a book. If he reads an average of 2 pages per minute, how many pages will he finish after m minutes? Write an equation and function notation to represent the scenario. Would it be continuous or discrete? What's the independent and dependent variable? And then finally, our new concept, what is the slope? So let's talk first. I'm going to kind of go out of order from the question. I'm going to talk about independent and dependent variables here. So I'm going to call this IV, and I'm going to call this DV. So independent variable, dependent variable. Remember, the last sentence of a question usually tells you what the variables are. So notice right here, this is the part that was the scenario. And it says, how many pages will he finish after m minutes? So your 2 variables are the number of pages and the number of minutes. So now you want to ask yourself, do the minutes depend on the pages, or do the pages depend on the minutes? And hopefully you're thinking the pages that Noah reads depends on how much time has passed. So here is our independent variable, and here is our dependent variable. What that does now is helps us create a table. So let's do number of minutes versus number of pages. Don't forget, you usually need to start with 0. So at the very beginning of the scenario, how many pages has he read? Hopefully you see it's 142 from the description. Let's say he's read for 1 minute. Hopefully you're saying, well, he's read 144 pages then. So how did you get that? You take 142 and you add 2 more pages. What if he reads 3 minutes? So hopefully you're thinking that you need to do 142 plus 6 pages, because it's 2 pages per minute times 3 minutes. Well, what if he's read 5 minutes? 142 pages to start with, and then 2 pages times 5 minutes. And remember, we can back up here and say 2 times 1. Here we can say 2 times 0. And hopefully at this point, if you say if we don't know the minutes, which we need to represent not with an x but an m, then it's going to be 142 plus 2 times m. So our final equation would be, let's say here we used m for minutes, let's use p for pages. So let's say p is equal to 142 plus 2m. So are we finished with that? Hopefully you noticed that I wanted it in function notation. So let's do that. We're going to change this so that it's not a p, but we need to put it in function notation. Be careful here. We can't say f of x because we didn't use an x in the equation. So what we're going to say instead is f of m is equal to 142 plus 2m. Remember, this variable and that variable have to agree with each other. Okay, so now let's do, so we've talked about dependent variables. We've talked about the equation and function notation. Let's talk about continuous or discrete. So remember, the question you want to ask yourself is, can he read a portion of a page? And is it legitimate for a portion of a minute to pass? Hopefully you're saying yes. And if your answer to that is yes, then the function is continuous. All right, and then finally, let's do the slope. What I would do here probably is go ahead and just use my table. At this point, we don't want to look at the breakdown. We want to look at our actual independent, dependent variables. So here, let's go ahead and say that this is 142, here's 144, here's 148, and then here is 152. So let's choose 2 points along that graph, and we've got our, even though we didn't use x and y, we still would be able to consider these, like our independent variable would correspond with the x in the equation, and the dependent variable will correspond with your y. So let's do like these 2 points here. So when we do the formula, think about this. Now let's change back to our x. This would be our x1, and this would be our y1 for the sake of the formula. This would be our x2, and this would be our y2. So now let's use those numbers in the formula. We're going to say slope is equal to 152 minus 148 over 5 minus 3. And 152 minus 148 is 4, and 5 minus 3 is 2, and that gives us 2. So our slope is equal to 2. Now, last thing is I want you to notice where that shows up in the equation. This is something we're going to talk about very soon. Notice the number 2 shows up in front of the variable. So keep that in mind, make a mental note, and we're going to come back to that and work with it more in later videos. All right, thanks guys. Have a good one.